January 2nd, 2025. The Minor Planet Center, the official body that catalogs space objects for the International Astronomical Union, identifies a new near-Earth asteroid. They log it, they track it, they add it to their database. One day later, they realize their mistake. It's not an asteroid, it's a Tesla Roadster. The car Elon Musk launched into space in 2018 as a dummy payload on SpaceX's Falcon Heavy rocket. They immediately remove it from the asteroid catalog. Embarrassed. How did they confuse a car for a rock? The answer is simple. They were trained to recognize rocks. Their entire system, their expertise, their pattern recognition, it's all built on a dataset of natural objects. Icy rocks, rocky asteroids, comets, and debris from our solar system. Nobody trained them to recognize spacecraft, because until recently, the only spacecraft in our solar system were ours. But what if that's changing? What if interstellar space contains more than just rocks? What if we're making the same mistake with Atlas that we made with the Tesla? Avi Loeb puts it bluntly in his recent Fox News interview. The foundation of science is based on the humility to learn, not the arrogance of expertise. When comet experts declared Atlas must be a familiar water-rich comet the moment it was discovered on July 1, 2025, they were acting like AI systems reflecting their training data. Decades of studying icy rocks in our solar system. That's their data set. That's what they know. But here's what they're missing. Humanity has launched technological objects into space. And if we can do it after just a few decades of spaceflight capability, what could civilizations billions of years older achieve? The numbers are staggering. There are roughly 100 billion stars like our Sun in the Milky Way. About 10 billion of them host habitable Earth-sized planets. Most of those stars are billions of years older than ours. In a billion years, our 1970s technology Voyager spacecraft could cross the entire galactic disk. That means there's been plenty of time for interstellar artifacts, potentially far more advanced than Voyager or a Tesla Roadster, to reach our solar system. Would comet experts recognize these visitors as technological if their training data only includes icy rocks? Probably not. And that brings us to Atlas, 12 anomalies. 12 separate observations that don't fit the natural comet model. Not one or two statistical outliers you could dismiss. 12. Trajectory aligned with our planetary plane, 0.2% probability. Sunward jets defying radiation pressure. 1,000,000 times more massive than Oumuamua while moving faster. Arrival timing that brings it near multiple planets while hiding from Earth at perihelion. Industrial nickel ratios. Only 4% water content. Extreme negative polarization never seen in any comet. Arrival from the WOW signal direction. Blue color at perihelion when it should be red. Jets requiring impossible. Surface area. Non-gravitational acceleration without corresponding mass loss. Collimated jets maintaining orientation despite rotation. 12 anomalies. And mainstream comet experts are largely ignoring them. Why? Because acknowledging them means uncertainty. It means admitting we don't have the answer yet. It means doing science as work in progress, rather than presenting finished conclusions. Loeb argues that scientists have become too risk-averse. They don't share their thinking until they know the final answer. They only speak to the public in press conferences once everything is settled, behaving like lecturers in a classroom telling students what they need to know. This creates the impression that science is the domain of an intellectual elite who already understand everything. But the truth is messier. Science is detective work, collecting evidence, testing hypotheses, sometimes discovering that nature is more imaginative than we are. Einstein was wrong about quantum mechanics having spooky action at a distance. He was wrong about black holes and gravitational waves not existing. Supersymmetry was ruled out by experimental data. String theory has spent 4 decades making no testable predictions. The mainstream is routinely wrong. And being wrong is fine, as long as you're willing to follow the evidence and update your views. That's what makes this moment so critical. We have an opportunity to do science publicly, to show people how we follow anomalies, to demonstrate the discovery as a process, not a pronouncement. The public responds to this approach. Parents write that their children want to become scientists after watching this investigation unfold. Hundreds of emails arrive daily from people fascinated by the mystery. Because here's the thing. People are far more interested in the search for technological life than the search for microbes. Yet the 2020 Decadal survey allocated over $10 billion to searching for primitive organisms and sidelined the search for technological signatures. Taxpayers fund science, and scientists should not ignore what the public cares about when setting research priorities. Interstellar objects offer both opportunities. We could land on one and return a sample to Earth, just like the OSIRIS-REx mission did with asteroid Bennu. If it's a natural rock, we might find the building blocks of life from another star, primitive chemistry, origin of life clues. But if it's a technological artifact, if we land on it and find buttons on the surface, then the fundamental question becomes, do we press them? That's the choice we're facing with Atlas. Do we approach it with the humility to learn, accepting that we might be seeing something our training data never prepared us for? Or do we insist it must be a rock because rocks are all we've ever studied? On January 2nd, experts mistook a Tesla for an asteroid because they were trained to see rocks. They corrected their mistake in one day. Atlas has shown 12 anomalies over 5 months. How long before we correct this mistake? The old paradigm says, everything from space is natural until proven otherwise. The new reality might be, some things from space are artificial, and we need to update our training data. December 19th brings our best observation window. The data will clarify whether Atlas is an exotic natural comet or something our expertise never anticipated. The question is whether we're humble enough to learn or too trained on rocks to recognize a spacecraft when we see one.